Okay, we're going to do 7.1 to 7.2 notes. And if you notice, I started on a different page than what the first page of your notes is. So please go to the one that the top of it says parallelogram. I'll admit I might have the notes be just a little bit rusty. Haven't really gone through them yet, so you get it as I do it, right? Okay. So we're going to first talk about a parallelogram. It's a quadrilateral with two pairs of congruent and parallel sides. So I drew some properties down here of a parallelogram. Opposite sides are congruent and parallel. So if you look here, I have my opposite sides are congruent. So those two sides are congruent, and then those two sides are congruent. And then they're parallel. So this side is parallel to this side, and this side is parallel to this side. Another property of a parallelogram is that the opposite angles are congruent. So this angle is congruent to this angle, and this angle is congruent to this angle. Another property is that the diagonals bisect each other. So diagonals mean if I draw a line from the diagonal, this diagonal to there, and then this vertex to there, then this length will be congruent to that length, and then this length will be congruent to that length. This point of intersection bisects both lines. Okay, and then same side angles are supplementary. So remember how we said opposite angles are congruent? That means that if I take A plus D, then they're going to equal 180. That's the definition of supplementary. Now before we move on, turn to page 7.6 in your notes, because I want to kind of orient us to where we are. We have a flow chart of some properties of quadrilaterals. Say we're talking about the middle one. A quadrilateral is a four-sided polygon. So if you notice, a parallelogram is a four-sided polygon. So I'm going to put a parallelogram right here under the quadrilateral family. You know, there's a couple special types of parallelograms, but these are all parallelograms that we're going to talk about today. They all share the same properties that we just went over, but they have a few extra. Okay, so I'm going to have you skip the questions down here between the differences between a rectangle and a parallelogram, because we haven't talked about a rectangle yet. We will in just a minute. We'll go there next. Okay, a rectangle is a quadrilateral, and we can also say now it is also a parallelogram with opposite sides congruent and parallel. And here's the extra part, and all angles are right angles. So I know we're skipping around a little bit, but if we come down here back to our parallelogram notes, it said what are the differences and similarities between a rectangle and parallelogram? The difference is the rectangle has 4 right angles. That's the difference between a rectangle and a parallelogram. Everything else is the same. So if I have my rectangle here, I say opposite sides are congruent and parallel. So I'll draw my congruent symbols now. So this side is congruent to this side. This side is congruent to this side. Now they're not all the same. They're not all the same length. Remember, a rectangle can have different side lengths, but the opposite side has to be the same length. Okay? And they're parallel. So remember, our sign for parallel is this little triangle. So that side's congruent or parallel to that side. This side we're going to do 2 triangles to show that this side is congruent to this side. So that was the same as a parallelogram. That was the first property of a parallelogram. All angles are congruent. So there's 4 right angles. Now this was a little bit different than the parallelogram. The parallelogram just said opposite angles are congruent. But remember, a rectangle is a parallelogram. So notice opposite angles are still congruent. But this is even a little bit more special. All angles are congruent. Okay. Diagonals are congruent, and they bisect each other. So where did my straight edge go? It's always nice when you're doing notes. Let me pause it. Did you miss me? I'm back. The diagonals are congruent and they bisect each other. So if I draw a diagonal there, and I draw a diagonal there, in a rectangle, the diagonals are actually congruent and they bisect each other. So this is congruent to this, and then this is congruent to this. So I just found another difference. On a parallelogram, the diagonals just bisected each other. But with a rectangle, the diagonals are congruent. So not only do they bisect each other, but they are also congruent. I just wrote this on my parallelogram properties page. Okay, back to my squares. Okay, same side angles are supplementary. Remember what supplementary means? They add up to 180. Well, that makes sense with a rectangle because they're all 90 degrees. So of course, if I had a rectangle A, B, C, D, if I took A plus D, I get 180 because they're both 90. Remember that was a property of a parallelogram as well. I wrote that's true for squares too, but we'll talk about that in a second. All right, let's go to the 7.6 page now. And notice that we had rectangle listed under parallelogram. The next one that we're going to talk about underneath a parallelogram is a rhombus. That means that a rhombus is also a parallelogram. A rhombus is not a rectangle. There's some differences here, but it is a parallelogram. So let's go to the page that says rhombus. Okay, a rhombus has 4 equal sides. So the difference, a difference now between a rhombus and a rectangle is that a rectangle did not have 4 equal sides. Okay, they just had opposite sides were congruent and parallel. So this is a little bit more specialized. All sides are congruent and parallel. So I can draw my parallel signs here. Okay, opposite angles are congruent. So that means this angle is congruent to this angle, and this angle is congruent to this angle. Now the difference here is they don't add up. They're not 90 degrees, they're just congruent. The diagonals bisect each other and they're perpendicular. So this is another special property about a rhombus is that if we draw the diagonals, this one and this one, to this one and this one, it's actually going to give me 90-degree angle all the way around. Notice now the diagonals are not congruent. You can kind of see from this picture this diagonal is bigger than this one, but they do cut each other in half, just like a parallelogram does. The diagonals also bisect the vertex angle, which means if I draw a diagonal here to here, that cuts this angle in half right there, and that angle in half right there. Then if I draw one here, then this is cut in half right here. Okay, let's go to the 7.6 now. Notes, last page of your notes. We're going to fill in now. The last one we're going to talk about is a square. Now I want you to notice that a square is a special rhombus. A square is also a special kind of rectangle. And a square is also a parallelogram. It fits underneath all of these. A rhombus, however, is not a square. Okay, so it goes this way. If it lies underneath it, then it fits in that same category. So let's discover why. Let's look at the properties of a square. is our first page of 7.1, 7.2 notes. I know I did them kind of backwards. I like it better this way. So a quadrilateral is a four-sided polygon. We already talked about that. Square, a quadrilateral with all angles congruent and all sides. So these are some specialized. A rhombus only had opposite angles congruent. And a rectangle had all angles congruent, but the sides weren't all congruent. So those were kind of the differences. So if all sides are congruent and opposite sides are parallel, those are the markings that state that. All the angles are congruent, so there's 4 right angles here on a square. That's why it can also be a rectangle. The diagonals are congruent, they're perpendicular, and they bisect each other. So that fits the definitions of the diagonals on a rectangle and a rhombus. So that's why a square is a rhombus and a rectangle. So I made the markings that they bisect each other, they're congruent, and they meet at a 90-degree angle here. And the diagonals bisect the vertex angle. So if this is congruent to this, now the special thing about a square is that since they're all 90-degree angles, then the diagonal makes these all 45 all the way around. Okay, and that's the true over here as well. Okay. Now we're going to use that information to complete some practice problems. So now that you know or have learned these properties, try putting them to use. Find the missing measures using the parallelogram below. So this is a parallelogram. Remember where that fits in our properties here? Up here. If you need to refer to your paper to see some of the properties, you can do that as well. So we're trying to find x. What did we say about the angles that can help us find x? A plus D. Let me find that and refresh your memory. On a parallelogram, I said A plus D, same side angles are supplementary, so they equal 180. Well, here I have 66 plus 2x equals 180. So 66 plus 2x equals 180. So I'm going to subtract 66 from both sides. Get 2x equals, never want to do math in my head on the spot in case I get it wrong, so I'm going to still subtract it. So it's 114. 2x equals 114. Divide both sides by 2. X equals 57. So I can fill that in right here. It says, well, what is h? Remember that opposite sides on a parallelogram are congruent, so they're the same. So if this side is represented by 16 minus h and this side is represented by 7, I can say 16 minus h equals 7. Then I can subtract 16 from both sides. Get negative h equals negative 9. Now I can't have a negative h, so I divide both sides by negative 1 and I get h equals 9. So put that there. Now the measure of angle B, if opposite angles are congruent, and this one's 2x, then this one is also 2x. Remember that we found out that x was 57, so 2x is going to be 114. Find the missing measures using the parallelogram below. So first thing it tells us to find is x. If we look here, all we know is that this is a parallelogram. Okay, and since x minus 1 is not pointing to this angle, it's pointing to the side right here. That's kind of confusing. But remember on a parallelogram that the diagonals bisect each other, so that means x minus 1 has to equal 9. And then if I add 1 to both sides, x is going to equal 10. Now this one, same thing. The diagonals bisect each other, so 15 has to equal 5 plus a. So if I subtract 5 from both sides, I get 10 equals a. Now f, opposite sides are congruent, so I can say 2f plus 2 equals 4f minus 16. 4f minus 16. I need to get my like terms gathered and on the same side, so I'm going to subtract 2f from both sides. I get 2 equals 2f minus 16, and then I can add 16 to both sides. If I'm going too fast, you know you can always pause the video and rewind it to see the steps. Divide both sides by 2. 9 equals f. That's one of the benefits of having it recorded. You can re-watch it. So then it says, what is the length of BD? This whole length here? Well, if this side's 9, I know this side is also 9. I don't even have to substitute 10 in for x. I could and say 10 minus 1 is 9. But it's just 9 plus 9, so it's 18. Okay, given ABCD is a rectangle, determine the following. So now that I know that it's a rectangle, let's see, the first thing it asks me to do is find ADC. So this angle right here. Okay, and if this is a rectangle, I know that has to be 90 degrees. So I can just fill that in. The length of DC, the way I'm going to find that is I'm going to set this side equal to this side and find out what x is. So 3x minus 5 equals 2x plus 3. Subtract 2x from both sides. I get x minus 5 equals 3. Again, if I'm going fast, pause the video, watch me do the steps. X equals 8. So if x equals 8 and I substitute that in right here, I have 3 times 8 is 24, minus 5 is 19. Okay, the length of BD, well, it says this side is 7, so that means this length has to be 7, so the entire length is 14. Angle DEA. So if this is 145, this is a linear pair right here, if you notice that. So that makes this one 35. Alright, one more set to go over here. Use rhombus SPQR to determine the following. So it says find SP, this side right here. And let's see what information it gives me. I know that all the side lengths are the same. This tells me that this is 12. I'm trying to figure out what it's telling me is 12. Oh, RP is 12. So that entire thing is 12. And this one is 4. Okay. So looks like if we remember about a rhombus, this meets at a 90-degree angle right here. So if this entire thing is 12, then let's see, I'm looking for SP. So if this entire thing is 12, then this side has to be 6 centimeters. Remember, this is a 90-degree angle. So if I kind of redraw this, might help you see this a little bit better. This is 4, this is 6. What's the third side? We can do the Pythagorean theorem to solve that. I'm going to pause it real quick and figure that out, and while you figure it out, you pause at the same time. Okay, I did that on speed just to make the video a little quicker, but 4 squared plus 6 squared equals x squared. Remember, the C part of the Pythagorean theorem is always opposite the 90-degree angle. So a squared plus b squared equals c squared. I solve for x and I get square root of 52. And that is perfectly fine to leave it just like that, square root of 52. Measure of QPS. So we have QPS. Okay, now remember that this diagonal right here bisects this angle. So if that's 17, then this is 17, which makes the whole angle 34. Remember, when I label it with 3 points, I'm saying that P is the vertex. Q just kind of says I go from Q to P to S. It kind of gives me a map. So then it's that vertex right there that I'm looking for. Okay, ABCD is a rhombus. If the perimeter ABCD equals 68 inches, so the whole thing is 68 inches, I just make myself a note right now. And BD is 16 inches. So this entire thing right here is 16 inches. Find AC. I want you to think about this one for just a second before I tell you the answer. Okay, it's going to take a little bit of figuring out everything we know so far. So what do we know about the sides of a rhombus? Think about that. They are all equal. So if my perimeter is 68, I have 4 equal sides. I can divide 68 by 4. That means every side of this perimeter, or this rhombus, excuse me, is 17 all the way around. It's helpful to remember we're looking for AC. This one, I kind of put a dotted line. Now, even though on this picture it doesn't look like it, if we go back to our definition here on rhombus, our diagonals are perpendicular to each other. So I have a right triangle right here. And I'm just going to redraw it. I might even make it look more like a right triangle than that one does. Okay, so that's right here. So I know this side was 17. If that whole thing is 16, then this little length is 8. And this is, I'm looking for that length. That's going to tell me that length. And then to find AC, I can double it. So I'm going to have 8 squared plus x squared equals 17 squared. 8 squared is 64 plus x squared equals, I think it's 289. Better double check because I'm on the spot. Correct, 289. So if I subtract 64 from both sides, x squared equals 225. The square root of 225 is 15. So this length is 15, which means this length is 15, and that length is 15. So A to C would be 30. Okay, read the next one. If ABCD is a square, the measure of DBC, so that's here to here to here, B is the vertex, is x minus 4. Find x. Now we have to go back to our properties of a square. This is a diagonal, and it cuts this angle in half. And I know this, every square has a right angle, so if this is half of that, then x minus 4 would be 45. I add 4 to both sides. X equals 49. That would be my x.